So we're recording this session now. So this is a Zoom video for December the 9th, 2019. It'll be the last one we'll do this semester, unless somebody wants a little video to maybe get a little tutoring or something. I'm going to put the camera down off my laptop so that when I write on the screen, it won't make a noise through the microphone. Let me get some things ready here. Okay, so we'll ready to draw on the screen. I think everybody knows how they should be preparing for the final exam. I've asked everybody to take the practice final on D2L. The password is EGSC. I think about 4 or 5 have done this now. I would hope that everybody would do this before the final. It'll give you some practice. If you make 90 on it, you get 3 more points on your final exam. If you make 80, you get 2. If you make 70, you get 1. Also, if you go to my website, there is another practice final that you can print out and work it. It's very similar to the one on D2L. And you can also check out the video in which I worked all the problems. In fact, let's just reiterate where everything is. If you go to my home page and click on Math 1001, everything you just about need to know is right here on this one page. From the daily schedule. So if you're concerned about any of the Zoom videos and notes for each week, we've got the Zoom link and the notes right here. For instance, if you want to pull up the notes for the 18th, there it is. One thing happened that many of you may not even realize. The server that my website was on, which also has the East Georgia schedules and a bunch of other things, somehow had some security issues, and they had to take it down last week, the same day my wife was going into the hospital. And by the way, she's doing fine. She had a good surgery, good results. But right in the middle of that, I learned that the links from D2L to the website were changed because they put it on another server with a different address. And I sent out a bunch of emails, well, actually an email telling you where you could go. And also the ITS, the IT department got in and changed the links and got everything straight. So you should be able to get to everything. The one thing I'm not able to do right now is update my website. So when it comes to the final exam review that we did on the week of December 2nd, I sent you out that and put it on D2L. And also for December the 9th, I will send you the link for this video that we're doing right now on December the 9th. Also, you can contact me if you need any help on any problem. I'm available. You can text me. You can email me and take a picture of a problem that you might be trying to work, and I'll be glad to give you some help. And this is just a reminder to complete the file on D2L for extra credit. And here again is extra points you can make. Already there are a number of you who have done this and have gotten some extra points. Now we're going to work some problems. As it stands right now, we have worked pretty much every one of the practice problems on my website. And they've been worked on the Zoom videos. They also, if you go to the video on all the practice final problems, you can see how they're worked. But what I want to do now is entertain any questions anybody has, and then work a few more problems, and then that will be it. So I've got a, does anybody have a question about any kind of problem or anything about the final exam? So unmute your.
No, sir.
Do you have anybody have a question?
I have one question about the final.
Okay.
It has to do with the time. I'm taking it at the Swainsboro Testing Center.
Right.
Well, I've never used the testing center before. Is there a specific time slot, or do you just come in that morning? Because I know
that's probably something. I think if I didn't say it in the emails or on D2L, they're only open between 8 and 5.
Okay, so it's just during.
It's a 2-hour exam.
Okay.
And I'm not sure that they like to have lunch, I think, between 12 and 1, although they might proctor at the same time. Usually I say if you're doing morning, try to do it between 9 and 11. That gives you nice 2 hours in there. It gives them lunchtime too. But I think they'll give it to you anywhere between 8 and I think anywhere between 8 and maybe 3 o'clock. They can't start one after 3 because you won't finish it unless you want to have just less than 2 hours on the test.
Okay. All right. Thank you.
Okay. Does anybody else have a question?
No, sir.
Okay. Well, we're going to work some problems. Some of these you may have even seen. This has to do with if P, then Q. And usually if the statement P is true, then Q is true. However, if P is false, then you don't know whether or not Q is true or not, but you assume it's true until you get some better evidence. Okay. So if horses have 6 legs, this is P, then Benjamin Franklin was the first president of the United States. Well, we know that P is false. So we can't decide. But we assume it's true until we get more evidence. So this would be true. Sounds sort of strange, doesn't it? Now, we've had a lot of probability problems, and we're going to work one that we've done before, and then one that we haven't done. You're dealt 2 cards without replacement. Now let me change this. You're going to be dealt 4 cards. So this has changed. You're being dealt 4 cards without replacement from A shuffle deck of 52 playing cards, find the probability of drawing 4 10s in a row. Okay, I apologize for not editing out this 2 there. There are 4 cards you're going to draw successively, and you're not going to replace any of the cards you draw. So you want to see what's the probability of drawing 4 10s in a row. Now there are 4 10s in a deck. So the probability of 4 10s in a row. Bear in mind, you're not replacing the card. Probability of getting a 10 in the first draw is 4 out of 52. In the second draw, since you're not replacing the 10, the probability of getting a 10 then is 3 out of 51. You got 51 cards left. On the third draw, the probability is 2 because you got 2 left and you've got 50 cards total. And then finally, there's 1 left out of 49. Now, if I'd ask you the probability of drawing 5 cards in a row, the probability is 0, right? Because there are no cards drawing 5 10s in a row. There would not be any left, so the probability would be 0. But anyway, this is a probability, and to get it in lowest terms, it's usually easiest to realize that 4 out of 52 is 1 over 13. 3 out of 51 is 1 out of 17. 2 out of 50 is 1 out of 25. And then 1 out of 49 is in lowest terms. And you multiply all that out, multiply all of these out, and you get 270,725. So that's the probability of drawing 4 10s in a row, which is a very small number. Now, suppose you're dealt 4 cards again, and you replace the card from a shuffle deck of 52, find the probability of drawing 4 10s in a row. Well, the probability of 4 10s is going to be different now. It's actually a little simpler to do. It's going to be 4 out of 52 for the first card. Since you put the 10 back in, the probability of getting a 10 the next time is still 4 out of 52. Third time it's the same, and the fourth time it's the same. And this is basically 1 out of over 13 to the 4th power. So it's 1 over 28,561. So the probability of getting 4 10s when you put the deck card back in is almost 10 times as much as if you as the probability would be if you didn't put the card back in. It's pretty easy to see why. Now, you're going to have problems on the normal distribution. And for the normal distribution, we use this rule. And by the way, you'll have this on the test. And we have the 68, 95, 99.7 rule to solve these problems. So the problem is, the first one you have seen before. The scores on a test are normally distributed with a mean of 105, standard deviation of 18. What percentage of the scores are greater than 141? Well, first thing I would do is I would put the data that you have on the chart. So we have a mean of 105. The standard deviation is 18. So we add 18 to that. And, excuse me, add 18 to that, and we get 123. Okay. Now all of a sudden, I hit something, and my pen is not working. Well, let's see what we're going to do here. Lordy, lordy. Okay. Now it's working. Okay, you tell me why it's working now. Computers are strange. Okay, now we'll add the 18 to 105 and get 123. And we'll add another 18 to 123, get 141. And I'm also going to put another 18 for 3 sigma, which would be 159. That's going to help us answer the second one here. So it asks us what percentage of the scores are greater than 141. So we want to know how much area is under the curve to the right of 141. Well, we know there's 100% under the entire curve. We know to the left of the mean, there's 50%. We know that between 105 and 123, there's 34%. And between 123 and 141 is 13.5%. We add that total up and we get 97.5%. That means that to the right, there would be 2.5%, which is 100 minus 97.5. So the answer is 2.5%. So I added another problem here to the same question. What percentage of the scores are greater than 159? Well, now we need to know how much area is out here to the right of 159. Well, we can do that a couple of ways. We can add to 97.5 2.35%, which is 141 to 159. And that would be 99.85%. So to the right of 159, in other words, data that's greater than 159, it would be 100 minus 99.85, which is 0.15%. So only 0.15% of the data is to the right of 159. as a probability, that would be 0.0015 would be the probability that the data would be to the right of 159. So I hope you've got a good feeling for working a normal distribution. Now, I know that you've done the 5-number summary of data using your calculator. I'm sure there's going to be a problem on the file in which you have to get the 5-number summary. Here is another one that's not from the practice test, but it's sort of similar. We want to calculate the data on the high school teachers, the number of years of teaching experience they have. And here is the data. And what you need to do is be very careful when you put this in your calculator. You got to understand how to manipulate everything. I would clear out everything, and we're going to go and start putting data in, and I'm going to clear L1. Okay. When you go into the test, you might want to just clear every one of your data listings here, L1, L2, and L3. I've still got stuff in my L2 and L3, but we're going to put the data in and be real careful. 33, 13, 1, 21, 31. Notice you got to check your work, otherwise you're going to get a number that's not going to be correct. 12, 2, 23, 25, 1, 33, 28. If you see me put something wrong, let me know, interrupt me. Okay, we got 6 in, now 18, 24, 22, 31. So we've got 19 data points in, and that's how many data points we have here. And you might want to go through and just check all of these. Okay, I'm going to assume I got it correct, and now I'm going to hit second data, and we're going to do statistics. Number 1, variable statistics. We're taking it from L1, so make sure you pick the right register, L1, and we're going to do 1 frequency. So we hit enter to calculate, and now we can see the mean, the standard deviation. The minimum is 1. Of course, all these have a minimum of 1. First quartile is 6. So we're down to either C and B. The median is 21. Notice the answer is going to be C here, which I've highlighted in green. And the third quartile is 28. And it looks like the maximum is 33. So the answer here is C. And what I would suggest is, since it's multiple choice, if you don't get one of these, you need to go back and put your number in and get it correctly. It's a little easier with multiple choice in that if you put something in wrong, you're going to automatically see you don't get one of the answers. Okay. Here's a problem here that I found on calculating expected value. We've already calculated expected value for things like a lottery, for a raffle ticket, et cetera, drawing marbles out of a hat. This is another game which is laid out here. I think I'll just go over it and show you how to calculate the expected value. Here you're playing a game using one die. It's got numbers dots 1 through 6 on it. Now, if you roll a 1, 2, or 3, the player wins nothing. If it shows a 4 or 5, the player wins $3. If it shows 6, the player wins $9. Now there is a charge of $1 to play the game. So what is the game's expected value? Well, you need to look at the outcomes. An outcome could be a 1, 2, or a 3, in which you would gain minus $1. In other words, you paid $1 to play and you would lose $1 because you didn't win anything. If you got a 4 or 5, you would win $3, but you paid $1 to play, so you would gain $2. And then if you finally got a 6, you get 8. You would net $8 because you would win $9 and you paid $1 to play. Now you need to know the probability of each of these outcomes. The probability of a 1, 2, or a 3, that's 3 sides of the die. So the probability is 3/6 or 1/2. A 4 or a 5, the probability is 2/6. And the probability of getting a 6 is just 1/6. So the expected value is a minus $1 times the probability of getting that outcome, plus $2 times 2/6 plus $8 times 1/6, and just do this math. And since everything is over 6, it's pretty easy to say this is minus 3 plus 4 plus 8 equals 9 over 6 equal $1.50. Well, I'd like to play that game all day because the expected value is $1.50, even if you have to pay $1. So anybody who's got this game set up and is paying this out is going to be losing money. But anyway, this is another example of calculating expected value. Now, somebody had asked about putting formulas into the calculator. I guarantee you we'll have some kind of compound interest. Here we've got one that's got a $3,500 deposit at an annual percentage rate of 5% with a monthly compounding for 6 years. We want to know how much you're going to have after 6 years. Well, R is 0.05. N is its monthly compounding. So N is 12, and T, in this case, is 6 years. So plugging into the formula, PV is the present value of your money that you're putting into the bank, and that's $3,500. So your future value, how much it'll be, it's going to be 3,500 times 1 plus 0.05 divided by 12 to the power 12 times 6, which, by the way, is 72. Now, you need to very carefully put this in your calculator. If you have this calculator here, let's go ahead and just, you can make it look exactly like it should. You're going to go 3,500 and I'm going to put in a parentheses, and I'm going to go 1 plus, notice I've got a fraction here, and so I'm going to pick n over d here, where I can exactly put 0.05 as a numerator and put 12 in the denominator. Now I need to move the cursor over to the right and put a parentheses here. I want to make it just look just like this formula. And I want to go to the 12th power. No, to the 72nd power. Now I'm just going to put 72 here, and I'm going to hit enter, and I get 472156, which is one of these answers here. So that's how much you would have after 6 years. Now you want to calculate the payments for a student loan. Wow, student loan of $79,034 with a very high, hope you don't have to pay 8% for 12 years. Here's the formula for the payment. That'll be on your sheet. The R is 0.08. Since we're talking about monthly payments, the N is 12 and T is 12. So plugging in, we get 79,034 times 0.05 over 12. I'm sorry, 0.08 over 12. Be sure you put the right data in, folks. And then you have in the denominator 1 minus 1 plus 0.08 over 12 to the minus NT, which is minus 12 times 12. Come on, let me make this a little neater here. So now let's do this in our calculator. Clear everything out. And I'm going to put 79,034. And I'm going to use parentheses. And I could do this without using a divide sign, but I'm going to go ahead and do that so it'll look just like we want it to. 0.08 divided by 12. I'm going to move the cursor over to the right. Notice I had to delete something there. Now I've got it looking exactly like this. And now notice what I didn't do, folks. I didn't start off with a quotient, which is what I should have. I can salvage this by putting parentheses around this. Say divide that by 1 minus 1 plus 0.08 divided by 12. And to the 12 times 12 is 144. To the minus 144. Come on. Well, this is not being very cooperative, so I'm going to clear the whole darn thing out again. I'm going to do it right. We're going to start off with a quotient, and now I'm going to do 79,034 and do a quotient again, which is 0.08 divided by 12. Move this over to the right. Put a right parentheses. Now I've got this done. And notice I've got room down here for my denominator, which is going to be 1 minus 1 plus, put my quotient in again, 0.08 divided by 12. Parentheses to the minus 144. I hit enter and I get 855 round off to 51. So the answer is C here. Notice that if you get messed up with the calculator and it's not letting you put in, like this app I've got on my phone, not on myself, on my computer, if it's not working right, just get out of it and start over again. But anyway, the easier part of this is it is a multiple choice test, and it should give you an idea of whether you're headed for the right answer. This calculator is a very good calculator, and you can, as you begin to put stuff in for a complicated formula, sort of get screwed up like I did. So anyway, there's the answer to that one. Now, number 34 here, you got a competition with 49 women and 21 men. 5 winners are randomly selected. What's the probability that they are all men? So you're going to have 49 plus 21 contestants. which is equal to 70. So you're going to have 70 contestants, and you're going to have 5 winners. So the ways to pick 5 winners is equal to combination of 70 things taken 5 at a time. And if you do this in your calculator, which is the best way to do it, you need to put 70 and then put probability, and we're going to do NCR. That's combinations of N things taken R at the time. And we're going to put in 5, the 5 at the time, and we get, wow, 1, 2, 1, 0, 3, 0, 1, 4. That's 12,103,014 ways to pick 5 winners. The ways to pick 5 winners from the 21 men, so there are 21 men, 49 women, would be 21, combination of 21 taken 5 at the time. And I'm going to let you put that in your calculator. And that is 20,349. So the probability of picking 5 men winners is going to be 2,349 out of the total number of possible ways to pick from the full 70. And you calculate that and you get 0.00168. Which is answer A here. You've seen this one before, except it's got a few different numbers in it. A restaurant offers 3-course meals with 2 types of salads, 4 different main courses, and 5 different desserts. How many different 3-course meals can be ordered? I think you know that by now. It's going to be 2 times 4 times 5 is equal to 40. The next to the last one here is a linear problem. High school pool record for the 100-yard freestyle is 47.1 in 1990. The record falls at a constant rate of 0.07 seconds per year. What does the model predict for the year 2016? Well, first we need to write down the linear model. If R stands for the record, it starts out at 47.1 and it increases 0.07 seconds or decreases 0.07 seconds per year. So the slope is minus 0.07 times t, where t is the number of years past 1990. So this is our model and it wants to predict what we want us to predict what it's going to be in 2016. Well, that would be 26 years later. So R is going to be 47.1 minus 0.07 times 26. Plug that into your calculator and you get 45.28. And that looks like it's answer B. 45.28 would be the record 19 years later, and there's a formula for it. Now, the last problem here, unless you've got other questions, is another expected value. And suppose you roll a fair dice and the outcomes are 1, 2, 3, 4, 5, and 6. And the probability of each roll is 1/6. And you want to find the expected value of what you would roll if you roll many, many times. You could say this is like a problem like suppose you got $1, or if you rolled a 1, you got $1. If you rolled a 2, you got $2. If you rolled a 6, you got $6. The expected value would be, to get a 1, the probability is 1/6. To get a 2, the probability is 1/6. To get a 3, the probability is 1/6. And finally, to get a 6, the probability is 1/6. So add all those up, and you get 1 plus 2 plus 3 plus 4 all the way up to 6, which is 21 divided by 6, which is exactly 3.5. So the expected value of the roll of a dice is 3.5. Of course, you never roll a 3.5, but you would expect the average to be, if you kept rolling a fair dice many, many times, that your average would be 3.5. So if you wanted to make this a game for somebody, you would have to assume that everybody's going to get an average of 3.5. And so you would want to charge at least $4 so that you would win out of anybody who played. If you didn't charge that much, then they're going to be ahead of you. Anyway, this is the last one on expected value. And does anybody have any questions about any kind of problems? We've covered just about every one I can think of. Does anybody have any more questions? Is anybody there?
I don't have any questions.
What was that?
I said, I don't have any questions.
Okay. Carissa, that was Carissa, right?
Yes.
Okay. I'm going to stop the share. Miranda may not be here. Miranda is still here. And Jason is still here. Jason,
Yes,
do you
sir.
have any questions?
No, sir. I'm pretty clear.
Okay. If any of you or anybody watching the video later has any questions before the final, give me a call and I'll help you try to figure out how to work the problems.
Okay. Thank you.
Okay. Good luck to everybody. I hope everybody does well. So hang in there and also work the practice final.
Thank you.
Okay. I'm going to end the meeting.
Thank you.
See you.